from the Alexander Kasser Theater at Montclair State University. The Margaret and Herman Sokol Science Forum on the Environment and Sustainability, the next 100 years. Now, Dean of the College of Science and Mathematics, Robert Prezant.
Good evening. I'm Robert Prezant. I'm the Dean of the College of Science and Mathematics here at Montclair State University, and it is my pleasure to welcome you to this very special forum on an issue of critical global importance, and one that we must all not only be concerned with, but that we must all actively be participating in helping to resolve. This forum is named in honor of Margaret and Herman Sokol. Margaret McCormick Sokol, Montclair State class of 1938, and Herman, class of 1937, were longtime friends and supporters of this institution. The generosity shown by the Sokols has been a palpable presence on this campus for many, many years, as represented by the Sokol Seminar Room in Science Hall, an array of scholarships and fellowships, the Margaret and Herman Sokol Science Lecture Series, this is part of that, and 2 endowed chairs. And the bequest from Dr. and Mrs. Sokol's estate of over $8 million will benefit students and faculty of the College of Science and Mathematics through the creation of fellowships, professorships, faculty awards, and the Sokol Institute for Pharmaceutical Life Sciences. Tonight's event, the Sokol Forum on the Environment and Sustainability, the next 100 years, is an event I know that Margaret would have deeply appreciated. Montclair State University is deeply committed to the concept of sustainability through construction of a recent green building, an on-campus composter, one of 3 in the nation, in fact, on a college campus, and through our New Jersey School of Conservation, the Passaic River Institute, and one of the only doctorates in environmental management in the country. This evening's event, then, is a natural extension of this commitment. Later on, Ira Flatow will be coming to the stage to moderate the panel discussion. He'll be coming up on stage just after our keynote address. Mr. Flatow, as many of you know, hosts and produces the National Public Radio's award-winning weekly program about science, Talk of the Nation, Science Friday, now in its 16th year. He's also founder and president of Talking Science, a nonprofit company dedicated to creating radio, TV, and internet projects that make science user-friendly. He has authored 3 books and many articles for magazines and newspapers. I won't go into more detail. We could go on and on. There are details in your program on each of our panel members and our moderator. Our keynote speaker is Dr. Michael Oppenheimer, the Albert G. Milbank Professor of Geosciences and International Affairs in the Woodrow Wilson School and the Department of Geosciences at Princeton University. He is director of the program in Science, Technology, and Environmental Policy, and faculty associate of the Atmospheric and Ocean Sciences programs, Princeton Environmental Institute, and the Princeton Institute for International and Regional Studies. He's author of more than 80 articles published in professional journals, and is co-author of a 1990 book called Dead Heat: The Race Against the Greenhouse Effect. Dr. Oppenheimer is a member of the Intergovernmental Panel on Climate Change, the IPCC, which won the Nobel Peace Prize in 2007, and served most recently as a lead author in the IPCC's 4th assessment report. This evening, Dr. Oppenheimer will discuss the global warming challenge. Can policy catch up with the science? It gives me great pleasure to introduce Dr. Michael Oppenheimer.
Thank you. And thank you for inviting me to speak here. Non-sustainability has many ugly faces, and this is one of them. This is the amount of carbon dioxide in Earth's atmosphere. As you probably know, certain gases that exist naturally in the atmosphere are transparent to sunlight, but trap heat that would otherwise escape into space. That's the natural greenhouse effect, and it's a good thing because without it, Earth would be about 60 degrees Fahrenheit cooler than it is now. It would be a frozen desert. Life would never have evolved, at least not at the surface, and we wouldn't be here to talk about this problem. The greenhouse problem arises because humans are increasing the levels of greenhouse gases in the atmosphere. This is 10,000 years ago. This is today. This is data retrieved from samples of the ancient atmosphere that one finds by drilling into ice deep below the surface of Antarctica or Greenland or tropical glaciers where air bubbles were trapped from the time that the ice was formed. And you can see that in the pre-industrial times, the level of carbon dioxide was fairly steady. But then recently, as is shown here in this inset of the last 200 years, it started to go up precipitously. That is an unsustainable pattern if I've ever seen one. Let's have the next slide. This is due, we know with certainty, and I don't say that about many things, we are certain that the buildup of carbon dioxide and other so-called greenhouse gases like methane and nitrous oxide, methane being the major component of natural gas, nitrous oxide being laughing gas. You know it as laughing gas, but it has many other sources. The main sources of these greenhouse gases, their amounts in the atmosphere have increased, and that is due to an increase in human emissions, and this shows the last 35 years or so of the human emissions of these gases, up, up, up. This pie chart shows the relative contribution. The dark area is carbon dioxide. Most of it comes from burning coal, oil, and natural gas. About 20% comes from deforestation, that is the cutting and burning of forests in the tropics, primarily for agricultural purposes. There's also some loss of carbon dioxide there due to timber harvesting. And this pie chart, which I invite you to study later, if you want a copy of this, I'll be happy to send it to you, indicates that it's not just burning of fossil fuels in industry to produce electricity or to power our cars, for instance, with gasoline, but also agriculture is a major source of the greenhouse gases. Let's have the next slide. The thrust of this talk is to introduce you to the problem and then walk you towards what a solution might look like. And the case I'm going to make is based on 5 key points. Number one, these gases, particularly carbon dioxide, have a very long lifetime. Once they're emitted, they remain in the atmosphere for decades, centuries, even millennia. Some of the carbon dioxide that we are emitting today, that you emitted when you drove to this meeting, for instance, will still be there in 1,000 years. Not a small percentage, a significant percentage, like 20%. There are changes in the climate already underway. We live in a different climate than we lived in 20, 30, 50 years ago, and the climate changes are accelerating. There are demonstrated limits in our ability to deal with the changing climate, the sort of changes in extremes of climate, more intense hurricanes, more heat waves, more drought, the sorts of things we expect based on our computer projections to happen more frequently in the climate of the future are just the kinds of things that human beings have difficulty dealing with today. The best example probably being Hurricane Katrina, the most vivid example, which itself probably had nothing to do with global warming, but it illustrated the complete ineptitude of government at all levels to help people deal with such extremes. We've also learned recently that even a modest warming on the order of 2 degrees Celsius, double all these Celsius numbers to get Fahrenheit, say about 3 to 4 degrees Fahrenheit, can bring about changes which are believed by many scientists to be unmanageable. Changes which would, for instance, entail very large increases in sea level due to the loss of significant parts of the major ice sheets in Greenland and Antarctica. And finally, the window of opportunity to avoid such warming appears to be closing rapidly. We need to act now. Let's have the next slide. This graph is, how many people in this audience saw An Inconvenient Truth? All right, so about more than half of you saw this graph in one form or another. Let me give you some extra information you probably didn't hear the first time. This has 2 records on it. This is the black is Earth's temperature over the last 400,000 years, again, inferred from those very same ice cores, this one drilled in Antarctica. The blue curve is Earth's carbon dioxide level, the amount of the levels of carbon dioxide in the atmosphere inferred from those ice cores. Notice that the carbon dioxide level and the temperature have marched together over the last 400,000 years. Indeed, we now have data back here, almost 700,000 years, which indicates the same correlation between temperature and carbon dioxide. Correlation does not a cause and effect make, and in fact, We do not know for sure exactly the mechanism that tied the big rapid increases in temperature and the big rapid increases in carbon dioxide. We have theories. We do not know for sure. We do know that these natural changes in climate as Earth swung from cold period, by the way, this is today, this is 400,000 years ago, from warm periods to cold, warm, cold, warm, cold, warm, cold, today warm, that happened, that was triggered by changes in Earth's orbit, which happened periodically naturally and which changed the amount of sunlight coming to one hemisphere or another during either summer or winter. And we also know that the large change in temperature from a cold period to a warm period cannot be explained unless you invoke the greenhouse effect that occurred, the change in the greenhouse effect due to this change in gases. So we have a theory which has been subject to an experiment by nature, a natural experiment, which confirms that over time, buildup of carbon dioxide contributed to the natural changes in temperature, although it did not initially trigger it. Probably what happened is a change in sunlight warmed the ocean, a little more carbon dioxide bubbled out, or melted a little bit of ice. Less ice on Earth's surface means less reflection of sunlight. That warmed Earth further. That pushed a little more carbon dioxide out of the ocean, and that led to a steep buildup in the amount of carbon dioxide, which then further heated Earth's climate. Either way, it's a confirmation of the greenhouse theory. We also know that in the previous warm period, 125,000 years ago, sea level was about 15 or 20 feet higher than today. And that's a number to keep in mind. It was only a couple of degrees Celsius, maybe 3 or 4 degrees, maybe 5 degrees Fahrenheit warmer in this period than it is today. That means we do not have a lot of headroom, as far as we can tell, to avoid a potentially very large and potentially catastrophic sea level rise. The other thing to note is that carbon dioxide levels are already up to here, 30% above any time in the pre-industrial record, 30% higher than at any time actually in the last 650,000 years. That means we are primed for a significant warming. Next slide. And as a result, in fact, climate has already started to change. This is Earth's temperature in the era of thermometer measurement over the last 140 years. It's gone up about 1.2 degrees Fahrenheit. This is sea level. It's gone up in response. It's gone up because water, like most fluids, expands when it's heated, and it's gone up because glaciers are melting and a little bit because the polar ice sheets are starting to fray away at the edges. And snow cover has decreased. That means if you go to Wisconsin, New Hampshire, Illinois, Minnesota, upstate New York, anytime in April or late March when the snow line, the edge of the snow cover used to be there, it's not there anymore. It's already further north. So temperature changing all over, sea level increasing, glaciers and snow melting. Extremes of heat and cold have already increased, and extremes of cold have decreased, as one would expect. Rainstorms have become more intense. Does anybody remember the April 16th storm here in New Jersey, which shut down the northern part of the state? That is the kind of event that we expect to increase in the future as the atmosphere becomes moister due to more evaporation from the ocean surface, and in fact, that process has already begun. Tropical cyclones like hurricanes are not more numerous, but they appear to be becoming more intense, and that is expected to occur even in greater amounts in the future. And finally, the ocean, which is naturally a basic material, a basic solution, is turning ever more in the acidic direction because carbon dioxide, as it dissolves in the ocean waters, is pushing it towards the carbonic acid. And that is bad news for shell-forming creatures like corals or clams, or anything else that has a shell, because they depend on the fundamental basic chemistry of the ocean, and as it becomes more acid, those shells will either dissolve or tend not to form in the first place. Next slide. Slide. Okay, so here are some pictures of things already happening. The red is the extent of the polar ice, floating ice cap in the Arctic in the beginning of the era of satellite observation in 1979. This white part, not this is the Greenland ice sheet. This is the floating the floating sea ice. This is the extent of the floating sea ice in 2003. The lowest summer sea ice extent was recorded this past year, and the total decrease in recent years has been about 25%, and that is simply going to continue, and the recent projections suggest that summer sea ice could be a thing of the past as soon as 20 or 30 years from now, or it could be as long as 70 years from now. The uncertainties are rather large. In any event, the Northwest Passage may become permanently open. That may become a permanent feature of our new climate. Next slide. Glaciers are shrinking. A glacier in Peru in 1979, same perspective today. This is not a particular glacier. This is a typical glacier. There's the data for the world as a whole in glacier length. 1700, 2000, it's down, down, down. Next slide. Everybody has a shot of a polar bear today. Since my wife took this picture, I have to use it. It's true that polar bears are spoken about a lot, and it's true they are a signal creature in this regard. They are typical of many species that live in particular niches. They do hunt off these ice flows. I saw it myself. I saw the kills. And as the ice flows go away, which they are, the habitat for polar bears will shrink. They probably will not go extinct because they'll wind up either in zoos or trying to encroach on land-based territory where they will be probably shot hanging over a garbage can in Churchill, Canada. That's probably where the last wild one will go. And this is typical of many species, and the Intergovernmental Panel on Climate Change projects that for a modest warming, only 1 to 3 degrees Celsius, about 2 to 5 degrees Fahrenheit, about 30% of all species, 30% of all species come at risk of extinction, and for greater warming, which is plausible during this century, if we do nothing about the gases, the rate of extinction only increases. Next slide. Humans are not immune either. This is the death rate in Europe starting in January 2002 and ending in August 2003. There was a humongous heat wave in Europe that summer, and the deaths of up to 40,000 people are attributed to the direct and indirect effects of that heat wave. 40,000 people. If you had asked any of my colleagues in the weeks before this, they would have said in advanced societies, in a highly industrialized society, no more than about 1,000 people could be expected to succumb in a heat wave. They missed it by a factor of 40. And look at this. This was a big influenza epidemic earlier that year in the winter. This is the heat wave deaths. It even outran a substantial influenza epidemic. And what is really disturbing is this figure here. This is the frequency of hot days in Central Europe, actually Central Western Europe. This is actually for Switzerland, in the recent past. So the data goes from about the last 100 years. And you can see, say it peaks. It's as if the peak were 85 degrees Fahrenheit, the typical summer day maximum in this region, with some days up around 90 or 95 and some days down in the 60s or 70s. The 2003 heat wave in Europe was way off. It was about here, as if it were the average over the 2 weeks. The average max would have been the equivalent of over 100 degrees 2 weeks in a row. But the interesting thing is, so it was a very unlikely event, but global warming, the greenhouse gases made it more likely. In the future, this is what the climate models tell us the distribution of hot days in a summer will be. Not this, centered around 85, but centered around the same temperature that killed 40,000 people in 2003. Now, by the time we get here, we're not going to be that stupid. We will have figured out ways, which we know already, we just don't do them, to protect people from heat. The trouble is, this was a once-in-a-thousand-year occurrence. By the time we get here, the once-in-a-thousand-year occurrence will become will be the typical summer. What happens when what's now the once-in-10,000-year occurrence starts happening every few decades, which is what you can expect in the future? We won't have adjusted. We will not know how to deal with that level or intensity of heat. Let's see the next slide. So these are things that are happening now. What's expected for the future? I put up all these colored curves because it tends to confuse people, and it's always good to take a break and a deep breath, and but don't focus on this too much. The bottom line on this is, if this is 1900, we've had this much warming so far. This is 2100. The warming in the future could be anywhere from here to here, depending on two things. One, how sensitive is the climate? Number two, how much greenhouse gas is in the atmosphere? We can't do anything about how sensitive the climate is, but we can affect the level of greenhouse gases. The amount of greenhouse gases will be determined by what kind of cars we drive, or will everybody fly around in their own personal levitation devices? I don't know. What will be fueling that personal levitation device? Are we going to still be using laptops, or will there be something even more amazing that uses even more electricity or less electricity? Maybe it'll be more efficient. We simply cannot project this with any intelligence. So we try to use a wide range of possibilities for what life in the future could look like. And this bar is our lowest guess about what emissions will be. This bar is our highest guess, and it could be anywhere in between. And depending on how sensitive the climate is, therefore, you could get a warming of a little more than 1 degree Celsius, 2 degrees Fahrenheit over this century to something like 6.5 degrees Celsius, about 11 or so degrees Fahrenheit. And we just don't know which we're going to get. But I can tell you that if we get a warming at this end, it's modest. We could probably deal with it in rich countries effectively, except along the coast there would be problems. In certain countries, particularly in the developing world and for ecosystems, this would be a real headache, but still probably not totally unmanageable except for certain species and ecosystems. But this, I don't know any of my scientific colleagues who don't think this would be a disaster. And the reality is we don't know whether we're going to get this, or anything in between. The only thing we have control of is emissions, and by reducing emissions, we can increase the probability that we wind up down here in the safer end than up here in the non-safe end. Next slide. Why should you believe any of this? Just because I say so, I'm a professor, so what? There actually are some ways that scientists peel this apart and try to get confidence in the fact that their computer simulations of the future actually work. The black curve in each of these cases is the actual measured temperature change over the last 100 years for each of these continents, North America, Europe, Asia, et cetera. Every continent except Antarctica, where there isn't enough data to play this game. The maroon area or pink area is the total projections of all 25 computer models of the climate that have been built in the different labs around the world. And as you can see, they, in each case, within a fairly wide margin of uncertainty, but still pretty impressively, reproduce the the continental temperature trend in each case. The blue area down here is what if you took the greenhouse gas buildup that humans have caused out of the models and you try to do the same thing? The answer is you get a crummy answer. That tells us the models are pretty good at projecting the climate of the past, so we can have some confidence that they're projecting the climate of the future correctly. Next slide. Other things that are going to change. Drying. The red areas are areas that are expected to dry. The blue areas that are expected to moisten with more runoff in rivers. On the whole, the Earth will be a little bit wetter because moisture will evaporate faster from a warmer ocean. But certain areas which don't have access to ocean moisture at certain times of year and are already dry are going to dry out, like it is projected, I might say. The entire Mediterranean basin, ranging from some very rich to some very poor countries, the southwestern United States, Mexico, other parts of the developing world here, which in some cases have trouble already with sufficient water for drinking and for agriculture. This bodes very poorly, and in fact, it is now projected that on the whole, because of increased drying and increased heat, food production in developing countries is likely to start decreasing for only a modest warming of a couple of degrees Fahrenheit. Next slide. I already mentioned the intense rainstorms like the one in New Jersey. There was an episode in Chiapas in Mexico a few months ago which caused a lot of problems. That's what this picture is. The areas in blue here are areas that have already shown increase in rainfall intensity. Here's the trend over the last 70 years, 65 years. That trend is expected to intensify further in the future. Next slide. Sea level rise, however, is the problem I worry the most about. The IPCC projected a sea level rise of up to about 2 feet during this century, but it leaves out possible changes in the ice sheets, which many of us believe could cause a sea level rise of at least 1 meter over this century. In toto, some people think higher. The red areas show the areas that would be below water, underwater, permanently submerged if there were a 1 meter sea level rise. Next slide. Some countries are in a lot worse shape than others. We got bad enough problems here, but in Bangladesh, the 1 meter line encompasses an area where 10 million people now live. Where are they going to go? Next slide. But this is what we do in preparation for global warming. This is my favorite town, Atlantic City, New Jersey. We allow, I'm saying this, the commissioner is here, so I wanted to hear it clearly. She knows, she's seen this slide. We let too much building happen too close to the coast, putting too much real estate exposed to global warming. I don't know what we're going to do. What does the combination of higher sea level, more intense, potentially more intense hurricanes, destruction of the barrier marshes back here, for instance, what does it mean? It can't be good. Next slide. But in the last few minutes of this talk, I want to emphasize the part of the problem that I think ultimately should benchmark where we slow it down, how we slow it down and how to stop it. This is the Greenland ice sheet. It contains an equivalent of about 7 meters of sea level rise should it all go into the sea. This is the Antarctic ice sheet. It contains an equivalent of about 65 meters, 60 in the eastern Arctic ice sheet, 5 in the western Arctic ice sheet. This part of the continent is probably fairly stable, and most of us do not believe, let me just put it this way, it would take so much warming to knock this out that I think humans are simply not that stupid that they would let that much warming happen. But this part of the continent and this part of this hunk of ice in Greenland are vulnerable for very modest amounts of warming. It looks like only a few degrees of warming could begin the process irreversibly of this chunk of ice and this chunk of ice slowly go into the ocean. That's 7 plus 5, 12 meters, about 40 feet of sea level rise equivalent. What temperature exactly would cause it to happen? We don't know. How long would it take once the process was started? We don't know. The estimates range from a few hundred to a few thousand years. A few thousand years rather, we could deal with it. We would gradually withdraw. It would not be pleasant, but wouldn't be the end of the world. Well, I wouldn't even call it a disaster. A few hundred years would be rates of sea level rise, which are so much faster than anything that civilization has had to deal with, that I feel quite comfortable in saying that's a disaster. We ought to avoid it. Next slide. This is what a sea level rise of either, not both, but either ice sheet disappearing, either the Greenland or West Antarctic ice sheet. This is a terrain it would take away in New Jersey, for instance, remarkable amount. Okay, next slide. And to show you how little we actually know about these processes, because I think it's important to remember in all of this, I've tried to emphasize how great the uncertainties are. This is a chunk of Antarctica called the Larsen Ice Shelf. It's the size of Rhode Island. It's floating ice, which apparently hems in ice, land-based ice and glaciers. If this melts, it doesn't raise sea level, but it does apparently let loose this ice, which then would start to flow into the ocean. These are melt ponds, and in January 2002, summer down there was starting to be melting on the surface because it's gotten very warm in that area in the last 50 years, partly due to global warming. It used to be thought that ice shelves like this would survive for centuries, if not a millennia even, until this area started to disintegrate. Now, this is 31 January 2002. Let's see the next slide. 5 March 2002, 5 weeks later, it's gone. Show that again. Go back one. January 31st, now go forward. One slide. Next slide. March 5th. It just blew up, essentially, because the meltwater got down to the crevices, floated the ice shelf apart into a million fragments, just like dropping a mirror, and then the ice in these glaciers started running into the sea, causing a measurable contribution to sea level rise. Fortunately, this part of Antarctica doesn't have a lot of ice in it, but the next most vulnerable part of Antarctica, where we're starting to see this process happen, contains an equivalent of about 1.5 meters, in other words, almost 5 feet of sea level rise. So it is of some urgency that we figure out what's going on here, and that we figure out what the limit on warming is that would be needed to stop it. Let's go to the next slide. So to summarize these arguments, this is Earth's temperature. This is a benchmark. This is actually from pre-industrial times. It's half a degree off the scale I've been using. Doesn't matter. I'm going to talk about it in general terms. This is the amount of warming that's in the bank. It's going to happen. Here's where we are now, by the way. Another half a degree or so is in the bank no matter what we do due to gases already in the atmosphere whose warming hasn't been fully manifested due to various lags. This is what happens to the temperature if we take a fast warming trajectory. If we just say, let's not worry about it, let's just keep doing what we're doing, and if the economies continue to grow fast. The EU has suggested a target around here. That is that we don't let the warming get above there, and the reason is that all this kind of bad stuff I've been talking about, reduced crop yields, 30% global extinction of species, and a potential lock-in of an ice sheet meltdown occur in this range. And notice there's a lot of uncertainty on these again, but the low points are uncomfortably close to today's temperature, so I'm worried about this. We could be lucky. We could have some breathing room, but we could be unlucky. Do you want to take the gamble? Next slide. So all right, now hit the next one on this too, because this has 2 panels. That's it. This is, given all the uncertainties, you could look at this like a roulette game. The most likely outcomes, if we just keep emitting the way we're doing today, are somewhere in here, that by the end of the century we'll be in the warming range of 2 to 3 degrees Celsius, maybe a little higher. That's 5 degrees Fahrenheit, and it's well above the safety mark on that last graph I showed you. But if we can reduce emissions, we can sort of eliminate the possibility of being at the very high end, the high end of those bars I showed before, and increase the size of the slots which only have a modest warming of a few degrees and keep us in the safety zone. And that's what I think the objective of policy on this should be. Next slide. So how can we think? Here are 5 things, 5 ways to think about what the governments of the world, not just the US, but all the governments of the big emitting countries should be focused on. Number 1, next slide. We have to learn how to adapt to warming better than we have. This is someone who succumbed during the Hurricane Katrina. We are likely to get more storms like that, and if not more intense hurricanes, more problems along the coast one way or the other. We aren't very good at adaptation. It's not fair. People are going to die if we're not careful. This should be the number 1 step that governments do, is figure out how to handle climate emergencies better. Number 2, next slide. We have to settle the developing country question. There's an issue called common but differentiated responsibilities in the so-called Rio Treaty, the Framework Convention on Climate Change, which says industrialized countries should go first in cutting emissions. By the way, these are the emissions of the industrialized countries. But developing countries, which are starting to follow behind, will obviously, their emissions are growing and are projected to surpass ours soon. In fact, China's emissions probably surpass the US already. We're going to have to learn how to make a cooperative deal with them in some way, because it can't be just on the backs of the industrialized countries, because that won't be enough. We won't have enough emissions, so there isn't enough to cut for us to keep the climate out of the danger zone. This has to be cooperative global action. Next slide. 3rd point, we have to soon bring technologies which are on the shelf but not being used or not being used enough, but which are affordable, cost-effective, and technologically available into the economy. For the US, that means that the next president, and each of the candidates has said they would do this, should see through legislation which would cap greenhouse gas emissions and then start to reduce them while re-entering the global negotiations to solve problem 2 I just mentioned. That's a hybrid. Next slide. By the way, in some of the good news, you might have read in the newspaper, Texas already gets 3% of its electricity from wind power, and the penetration of wind is growing at 45% per year. So there are some good things happening. New technologies which could help us solve the problem over the long term have some promise. It is possible we could continue burning coal if we could find a way to trap and bury the carbon underground. Now, actually, we can do that. It is done for other purposes, not electricity generation, for instance, enhanced oil extraction. But it's never been done for power generation at scale. And the major point is we don't know how long the CO2 would stay underground. If it stays underground decades, it doesn't do any good. If it stays underground centuries, it can help us solve the problem. Other technologies like advanced photoelectric cells, and there are big advances happening in photovoltaics. Some people argue advanced nuclear power. I personally am skeptical of that. And other renewable energy sources could help us over the long term turn all these curves down. 5th point and final one is that we have to learn to live in a world of uncertainty. We have to learn to be flexible. The bottom line of my talk isn't just scary stuff that's going to happen. It's that we live in a world where we're changing it faster than our ability to understand it is changing. We're changing it faster than we're learning. And we have to be prepared for surprises. We have to be prepared for outcomes that are different than what I just told you to some extent and to what we would normally expect. Being fast on our feet, learning to develop an economy that is truly sustainable is the only way we'll have that kind of flexibility. Thank you.
Hi, my name is Ira Flatow, and I want to thank you now to take part, invite you to take part in the rest of our program, because this actually is up to you to talk about the issues that have been raised today. And it was very interesting when Michael was talking about changes in this century. Being here in New Jersey, the George Washington Bridge celebrated its 75th anniversary not too long ago, being built, designed and built. And I interviewed one of the architects of the bridge. He must have been in his early 20s. I interviewed him a few years ago when they were talking about the celebration. And I said to him, what did everybody do before the GW Bridge was there? He said, in the wintertime, we walked across. It's hard to believe that the Hudson was frozen solid over at that point just 75 years ago. That's how much colder it was in that time in the wintertime in the climate. So for the rest of the hour, maybe we got about 60, 90 minutes to go. It's your turn to do some talking, to tell us what you think about the environment and sustainability. We have assembled a panel of experts who will be happy to answer your questions and talk about the challenges facing any society that embraces a sustainable future, because I believe it's going to take a cultural change, including you, the public, business leaders, governments, all working together, as Michael was showing there, about how we are all going to have to tackle this in the future, and cooperate, not just within the states, but within international societies. And so we'll be welcoming questions from you from the audience. There are going to be a couple of floating microphones around. Have we got the microphones out that we can find out where they are? If you have a question, they'll be coming to you in the aisles. Raise your hand, the microphone will find you, and hopefully you will be able to ask your question. I also want you to look around at each other here, because we have an overflow crowd of people in this auditorium. Almost 500 people have shown up tonight to discuss the environment and sustainability, and I think that shows the kind of paradigm shift we are actually going through now that we have not been experiencing in the last decade or so. So rather than listen to me babble on up here, let me introduce our guests and get to the discussion about what we see as the future. Let's start on the end. On the end of the aisle is Eric Svenson. He has spent his professional career with PSEG. You know what PSEG is? It's a power company. And he's currently serving as Vice President of Environment, Health, and Safety at PSEG Services Corporation. He joined the company in 1973, working in electrical generation operations. He developed the first phase of a plant maintenance optimization program. Mr. Svenson earned a Bachelor's of Engineering degree and a Master's degree in Engineering from Stevens Institute. He's a founding board member of the Northeast not-for-profit Clean Air, Cool Planet, and serves on the board of the trustees of the New Jersey Nature Conservancy. And over the years, Mr. Svenson has provided testimony at numerous New Jersey, Northeast, and national legislative and regulatory forums. Welcome to the program. Thank you. It should also be noted, go ahead, you can, sure. It should also be noted that PSEG was presented with the Coastal America Special Recognition Award by the White House Council on Environmental Quality. So we should point that out also. Let's go down the list. Andrés Edwards is an educator, author, media designer, and sustainability consultant. He's founder and president of EduTracks. That's a firm specializing in developing education programs and consulting services on sustainable practices for green building and business initiatives. He is the author of The Sustainability Revolution, Portrait of a Paradigm Shift, and co-author of Tibet, Enduring Spirit, Exploited Land. He also holds an undergraduate degree in geography from the University of Colorado, an MPS in media studies from NYU's Interactive Telecommunication Program, an MA in humanities and leadership culture from the New College of California, Santa Barbara, and he is a lead accredited professional. Welcome to our panel today. Thanks. Also with us, we're very lucky to have with us tonight also Ms. Lisa Jackson. She is the face of the Environmental Protection of New Jersey. She's the commissioner of the New Jersey Department of Environmental Protection, and prior to being named commissioner, she served as DEP's assistant commissioner for land use management and as assistant commissioner for the Division of Compliance and Enforcement. Before joining DEP, she served for 16 years with the U.S. EPA, initially at its headquarters in Washington, and then at its regional office in New York City. Boy, she must have stories she could tell about things. She holds a bachelor's and master's degree in chemical engineering from Tulane University and Princeton, respectively. Thank you. Welcome, Lisa Jackson, to the panel. And you all know Dr. Oppenheimer. I just want to point it out that in reading and listening to Dr. Oppenheimer talk about global warming, I pulled up a book he wrote in 1989. We're talking over 25 years ago about global warming. People think this is a subject that just came up yesterday, but Dr. tell us how long this has been being talked about.
Well, I mean, it's over 100 years old. The first scientific theory was 1896. Nobody paid that much attention except for a few scientists. But in the 70s, in the late 70s, it first became an issue in the U.S. government.
Now, let me begin with where you left off. You said you see, and this is a very big New Jersey issue, you said you see one of the greatest challenges to the coming years is the rise of sea level. You know, when every storm, if you watch the news now, when every storm, where is the first place the news people head to? They go to Seabright, right? They're right there on watching these storms smashing up against the coast. Now, let me ask our panelists, what do we do? And this is such a big issue and will cost so much money. How do we begin to tackle the inevitable rise of the oceans? Let me ask you, Michael, to begin, and we'll head down the panel. What do you suggest? Where does this begin?
Well, with sea level rise, it has a certain inexorability, and the only way to get ahead of it, if you can get ahead of it, is really, it's the main reason, in my view, to start reducing emissions soon. Because once it gets built into the system, you can't stop it. But beyond that, we need shrewder coastal planning to, create some disincentives for building so much along the coast. And we need, to have a better way to deal with emergencies like Hurricane Katrina, where we showed, as I said several times, our complete ineptitude. So a comprehensive program, reduce the vulnerability at the coast by not, letting everybody build anywhere, being proactive about things like evacuation plans, and ultimately cutting emissions as soon as we can, because, it just has a 1,000-year momentum once you let it start.
Is it a question of building, dams and dikes and things like that? Is it going to come down to that?
It may be. I live in Manhattan. That's very valuable real estate. It's hard to imagine we're going to withdraw. In certain places, there will be withdrawal probably if it gets out of control. But they'll probably build, seawalls, and there is a plan that I was just at a meeting for the other day, which has a barrier built at the Narrows, a barrier built on the East River, and a barrier built in Kilvan Cole. That may be the future.
Yeah. Lisa, someone who went to Tulane, who knows New Orleans, and here's now us talking about seawalls in New Jersey. What do you expect to happen?
Well, I'm an engineer, and I'm also a native New Orleanian from the 9th Ward. So that picture meant a lot. I knew exactly the street that Dr. Oppenheimer had found. So I think there are a few things we have done, but the challenge in New Jersey, as in much of our country, is to unmake centuries of landscape. We don't get to erase and start all over. And even sadly, tragically, in my hometown in New Orleans, where nature does some amount of erasing, even there, starting all over has proven to be politically very difficult. Because at the end of the day, folks aren't really ready, even in the face of that kind of tragedy, to necessarily embrace drastic adaptation and change. But I think there are several things we absolutely have to do. There are engineered solutions for sure, but the first thing to do is to recognize that in a time when we're not building as much, we have an opportunity to redevelop and to use every redevelopment opportunity as a way to build in some form of adaptation. So whether that's height on a building to ensure we're not living within the flood zone, whether it's to ensure we engineer adequate evacuation routes, which obviously on our coastal areas, on the barrier islands is tough, but those are vacation communities for the most part. But even inland on the tidal waterways, and we're pretty tidal in New Jersey. The head of tide goes all the way up to Trenton. It goes all the way on the Passaic River, pretty far up. I mean, there are lots of places that are going to be affected by flooding, and then, of course, inundation that comes from our streams. So I think we have to take advantage of every redevelopment opportunity. The one thing the governor did, and I don't want to turn this into a political lecture, but we have, I think, some of the toughest flood hazard rules in the country. We have a Flood Hazard Area Control Act, and we have rules that are all about slowly trying to change the face of that development. That being said, we have an extremely developed coastline, and those battles, Atlantic City is a great example of where we've invested and where we have an engine for economic growth that, like Manhattan, isn't likely to go away. So there we have to look at moving residential uses back and trying to preserve our salt marshes.
Another thing that Dr. Oppenheimer mentioned was capping greenhouse gas emissions. Does the state have a plan for how to do that?
The state has a law, and we're getting closer to a plan, to be honest. We have the Global Warming Response Act is the law of the land in New Jersey. It mandates scientifically based, that was something we were really proud of, reductions in greenhouse gases, 20% by 2020, 80% by 2050. And at the time we did 80%, we thought we were pretty cool. And then now Europe is talking about 0% or negative emissions. And you might ask what that means. Well, that's Dr. Oppenheimer's point about certain places doing more so we can trade off on less. And when they do more, when Europe says we're going to get down to 0, they don't really mean 0. They mean we're going to invest in offsets in developing countries in order to make ourselves carbon neutral by investing and getting low-hanging fruit there. So we thought we were pretty aggressive at 80%. We don't have a plan yet because we have until June, and we're pushing that envelope to come up with a suite of measures that we owe back to the state for a year of public comment and peer review in terms of plans for moving the state forward.
Let me ask you, Andrés, what kind of plan would you think or would you hope that governments take? What should people do to try to lower their carbon footprint?
Well, I think one of the key things is to think and to make the link or the feedback loops between climate change and our daily activities. In a lot of my work with colleges and universities, we sit down with the different stakeholders, including students, faculty, IT staff, and say, okay, we take a needs assessment. What are your challenges right now in terms of reducing waste and reducing energy and dealing with water conservation, in terms of local food resources? So we begin to tap into this knowledge base and figure out where are they now, what can be done in terms of daily life, like electricity, light bulbs, in terms of transportation, not just looking at hybrid cars as a solution, but taking the larger vision, which is really transportation. How do we move from here to there? Our food purchase, how much of it is localized? There are many restaurants now that are saying they get all of their local food from within 100 or 150 miles. How can we get college campuses and communities to start applying some of these ideas? Farmers markets are really taking off in that way all over the country. So I think the more we can link it to daily activities, the more we have a chance to make progress.
What if we offered free toll on the Jersey Turnpike for hybrid cars or something?
Well,
debt reduction. Well, so we have these conflicts, right? There are these conflicts about debt reduction versus toll. Some states I know where I live in Connecticut, they'll give you don't pay taxes for buying a hybrid car. You don't pay taxes on personal property taxes at all. Mm-hmm. And so there are these sorts of incentives.
Yeah.
Let me ask you, as someone from the, Eric, someone from the power company, are there extra things the power company can do to help us use power more efficiently, we as consumers? And to help maybe give us incentives to do our laundry at night when the power is
Sure.
not in such great demand?
Ira, there are a lot of things that could be done. One thing obviously is we call it the low-hanging fruit is energy efficiency and conservation. It's amazing is when you realize that there are many economic things that can be done today, but consumers are not using those economic tools that are in front of them. For example, you go into Home Depot and you look at a light bulb, there's two types of light bulbs. There's a CFL called a compact fluorescent bulb, and there's an incandescent bulb. The incandescent bulb costs maybe 60 cents. The CFL is 4 times that, 5 times that amount. People buy on an initial price as opposed to looking at the savings. The compact fluorescent bulb has an energy savings that's 4 to 5 times that of what the uses 4 to 5 times less energy than what the incandescent bulb is. But again, what consumers do is they buy on the first time cost as opposed to the long-term savings. What the energy company can do is actually find ways to help make inroads to get customers to use those new technologies, i.e. whether it's a compact fluorescent, more energy efficient furnace, a host of things. The next area is really renewables. Renewable energy, we applaud what the governor, for example, has done, and Lisa, the governor set forward an energy master plan this past year that said we're going to achieve a 20% energy efficiency reduction by year 2020, and our target is to achieve a 22.5% renewable supply by 2020. Those are very aggressive targets, but we think those are the right targets. But to make that, we just don't think it's going to be simple rebate programs that are going to achieve it. You're going to need companies and entities that can bring capital to the table and who have working relationships with customers and know how to deploy large sums in the customer's best interest, in the public interest. Our name, and I'll finish this shortly, but is Public Service Electric and Gas. The name public service wasn't just something that somebody just had a bright idea one day. It was originated 100 years ago because we were created to serve a public good. We're successful today because we have been serving that need. The customers are demanding, in light of the climate change, that energy efficiency renewables are the place to be.
Are you willing to bring in more green electricity?
Yes.
Into the state?
The big challenge, let me just say, is, it's very interesting. The way utilities, we're not a government entity. We are an entity that has shareholders, and the shareholders expect to get a return on their investment. We've been granted a franchise for providing universal service to all at a reasonable cost, delivering power at an environmentally responsible manner, and making sure it's reliable. The way we do that, though, is we get paid on quite honestly, a throughput basis of kilowatt hours that are sold. We need to change that regulatory compact. We need a way to say that what the utility industry in this country should be rewarded to put as much investment into energy efficiency and renewables and get paid for that in the same manner as they would have been paid as being paid in hardware, transformers, pipes, and wires, and so on.
If you have a question, raise your hand. We'll get the microphone over. There's a gentleman there, and we get the microphones over to these people. We'll go right to some questions. We have a few questions coming in from the internet, so we'll get to them too. But if we have one there, yes, go right ahead.
I have two.
Stand up, please.
Boy. I have 2 brief questions. Hopefully they'll generate a bigger discussion. One is, could you please discuss the impact of meat production on global greenhouse gas emissions? And the second is it true that the amount of corn that would go into the ethanol that would fill one tank in an SUV is enough to feed one person for a year?
Was that wheat or meat production? Meat production.
Well,
Michael?
There have been several analyses on the question of a vegetarian versus a meat-eating diet. And when you take all the greenhouse gases into account, including the fact that cattle burp a lot of methane, comes out the other end too, but in lesser quantity actually. It turns out that a vegetarian diet would be an overall benefit in terms of greenhouse gases emitted. I don't have the exact numbers. So, under the principle that if you sort of are a scold and tell people what they have to do, they won't listen to you, I wouldn't exactly go around and be I myself have a low meat but not a zero meat diet. I think it makes sense to, where you can and consistent with your own tastes, try to shift the balance in your diet away from meat. There are other reasons for doing so, of course. I don't have the specific number in terms of ethanol, corn ethanol in my head, but I can tell you two things that you ought to know about it. First of all, corn ethanol, as it is produced in this country, on balance, everything considered, does not produce any greenhouse gas benefit. There are several reasons for that, including intensive energy use and the fact that the land cleared to grow the corn shifts crop production, generally soybean production, overseas where it's accomplished by clearing virgin land and trees are cut and burned. The second thing you ought to know is that in the future, it may be possible to produce ethanol in this country from what's called cellulosic processes, which would be efficient enough so that it would be a viable greenhouse gas reducing source. But at this point, the only ethanol on the planet probably that does any good as far as the greenhouse effect is concerned may be Brazilian sugar cane based, but even there's some question because we don't really know what the land that was cleared to grow the sugar cane had on it beforehand.
Yes, Andrés.
Yeah, just a bright light in the whole biofuel scene is that the European Union just recently passed a law where they're going to be requiring third-party certification for these palm plantations where they're clearing virgin land for biofuels. So there's an effort now to really try and narrow down how this is produced and to make sure that we're not clearing forests to do so.
There are a lot of other very interesting alternative energy projects that you don't hear about unless you look for them. And one of them I've discovered is algae. Believe it or not, algae will grow just about anywhere. You can't stop it from growing in some places. And there are companies out in the Southwest that are actually in the algae growing business. Because out of growing algae, it basically sucks up CO2 from the environment. And there are 10,000 species of algae, and you can choose the one that you would like to produce the energy for you the most beneficially. For example, there's algae that's good at making more sort of biodiesel. It'll make oil for you. There's algae that you can ferment the cellulose of it. You can ferment the algae into alcohol, and then when you're left with the protein, you can feed the cattle. So you can take algae and make all this energy for you and get 3 bangs for your buck out of it. And there's actually a demonstration plant and a power plant out west that has been growing algae in a greenhouse and taking the exhaust emissions from the power plant. This is a natural gas power plant, feeding it through the greenhouse, and the algae is soaking up 80% of the CO2. It doubles in size overnight, the algae. That's how efficient it is in cleaning this stuff up. So there are a lot of other interesting things going on. Solar has other interesting things on thermal solar reflectors. And if you really are interested and people are really interested in finding out how these alternatives are working, it's quite an education to see that even though we concentrate here in certain areas on one kind of alternative power, other places are concentrating on other areas on alternative power. It was interesting that Michael mentioned Texas and wind. Texas took over. Texas was beat California out. California used to be #1. But most interesting to me is that the wind revolution began in Texas under George Bush's administration. And if you ask people what happened when he got to the White House, they don't know what to tell you, how this thing sort of fell down. Yes?
Ira, the only thing I'd like to jump in on is, because I want to make sure the audience, I have a point of view, I guess, is let's go back to what the state has been trying to do. 20% energy efficiency by 2020, 20% renewables by 2020. Why is that target, for example, not 100% renewables? Okay, well, it really comes down to is how expensive is this going to be? Are really the resources there? How much land area does it take to put in a solar array? For example, the nuclear power plants down in South Jersey, controversial item. Third item we believe in is ultimately is going to be needed is new nuclear power. But to replace the nuclear power plants in New Jersey with photovoltaics would require an area the size of Hudson County, okay, of a solar array at a price of about $200 billion. That's about the equivalent of doubling New Jersey's property taxes for the next 7 years. Things are doable by technology. The issue is price. It's been price all along. A lot of people have said in this country, the country doesn't have an energy policy. It's had an energy policy since the first Arab oil embargo, cheap energy. That cheap energy has stood in the way of actually people are buying SUVs, 15 mile per gallon, 12 mile per gallon, homes, McMansions that are 2 hours away from the place of work. All those greenhouse gases as a result of cheap energy. That is something we're going to have to learn to accept. It's going to be more expensive.
Yeah, do you want to?
Can I jump in one more time? I want to give you time for questions, but since we mentioned the state, when I talk to groups about climate change, I like to ask you to think about New Jersey for a second. New Jersey's a great state, 138 miles of coastline, most densely populated state in the country. So when you look at renewables that are, talked about and sexy right now, solar requires space. And so you just heard some of the economics, at least for now, on solar. We are not a place that has a lot of space. We can put it on top of buildings, and if you hear the governor speak, he'll say we're big on logistics and warehousing. They're springing up everywhere. That's probably one of our growth industries. We really are missing an opportunity on all those flat roofs. So there is some work on solar that I think is going to expand with the new solar program.
Why not? Can I just interrupt for a second and change the paradigm a little bit? Why think about New Jersey? Why not think about piping the electricity in from the Southwest where there's plenty of sunshine? And you have a plant, you have facilities out in the Southwest to make electricity. Why can't you make that green electricity out there and pipe it back to Jersey?
If I could jump in on that then, is you can transmit power long distances. And we have an interconnected grid. Most people don't realize that New Jersey is a net importer of its electricity. We're part of what's called the PJM grid. It extends all the way out to Illinois. That's interconnected to something called the MISO grid, which is all the way out to Wisconsin and parts of well into the west. So we do transmit power over long distances, but there are line losses. Another factoid, electricity produced from the plant to the time it gets to the consumer, 8% power loss, energy loss. That has to be fixed, but that's the problem. Long distance, energy loss, that's what needs to be overcome.
Yes, go ahead.
And yet at the home level or at the individual level, family level, there are, in California at least, many incentives that are really promoting and can cut the cost down by 40 or 50%. So if we can create these mechanisms, the city of Berkeley recently passed a program where they're going to try and facilitate the funding of solar through their property taxes. And it's the first in the country to try that. But there's another experiment there to see how can we make this more affordable? How can we push forward with these ideas at the more localized level?
The only point I'm trying to make is that when we talk about the cost of energy, and it's a good topic and a good one to talk about, when we talk about the cost of doing it, we don't compare it to the cost of not doing it. Mm-hmm. We don't compare it to the cost of what's it going to take to keep the ocean back. Of all the coastline there, what is it going to cost to build these dikes versus now let's lower the CO2 levels, pay a little bit up front, reap a larger benefit down later when we don't have to, worry about the ocean coming in our living rooms.
So, Ira, the only thing I want to be clear about, I am not saying that we are saying is we're against any of this. What we are saying is there needs to be a frankness in the public dialogue process to educate customers, educate the public, that it is going to be a more costly environment. We think that can be a very sustainable environment, but we need to start to condition people that prices are going to go up, and that is going to be reality. Too often we run away from that topic.
Right. It needs to be a national dialogue,
yes,
doesn't it? And you can't depend on everything for yourself in New Jersey or any other state. There needs to be a cohesive national energy policy that brings everybody together. Can take the electricity from Texas, so they're not on the main grid, or some other place in Nevada or wherever they can build these giant solar collectors and find a way to take the wind out of Kansas and places like that and bring it all onto a grid someplace. And that's, to me, that's how you spend $200 billion, if you want to invest it in the infrastructure. I'm off my soapbox. Who's got a soapbox out there? Yes, who's got it? I saw a hand up for, yes, right here. Question right here on this side.
Mr. Stevenson, you keep speaking about
Speak up,
this,
speak up.
you keep speaking about this 20% reduction in energy, but as our population grows, will this 20% increase be more of an offset of the increase of energy use rather than a gain? And you speak of cost, but what of the cost of offsetting the effects of global warming? Will that end up being more costly in the end than just reducing emissions now?
Yeah, I'll talk about it from a public policy perspective, and I kind of want to go back to where I was going before. One quick thing, they're a power company, but they recently bid on an offshore wind project. Governor Corzine thought that we have to find a way to get renewables in our portfolio as well and try to break through the offshore wind barrier. So the state has a solicitation out. We have, I think, 5 bids that came in during that solicitation to put some offshore wind in New Jersey. And we're hopeful that maybe we've come upon a paradigm that means we'll actually get something built and not just announced. So I just have to say that that renewable in New Jersey, we don't have a lot of onshore potential for wind, but we have some potential for offshore wind generation off the coast. What I was going to come back to, and I don't have the numbers in my head either, is that one thing we have in New Jersey is people, densely living. In some ways, there are areas of New Jersey that model how we would love to see people live and work and commute. The areas around New York City, the areas around Philadelphia, and more, we have to take that model, and even if you don't work in one of those 2 cities, make it so that you're in your own bedroom community. So that's the whole land use conundrum. But we also have to build in and retrofit for energy efficiency. In my mind, we have tremendous amounts of work to do, and the state has been here before at the brink of embarking on almost a public works project to get energy efficiency in our schools, our businesses, and most importantly, our homes, our apartment buildings. We could save a tremendous amount of energy. The cheapest energy you buy is the stuff you never, ever use. The cheapest CO2 reductions by far, every study shows they will pay for themselves if you don't have to burn the fossil fuel in the first place. So all that offshore wind is great, but there's a tremendous amount of low-hanging fruit, and it's in the form of energy efficiency. And because we have so many people living so closely, that multiplication factor means we can see some tremendous reductions in energy usage.
Do you think we'll ever see mandatory caps on CO2 emissions in New Jersey?
Yeah, in New Jersey is part of a 10-state compact called RGGI, the Regional Greenhouse Gas Initiative, and we will be, I'm still convinced, the first mandatory cap-and-trade program for utilities in the country. California and the western states are behind us. The Midwestern states have announced their intention to try to do a cap-and-trade program as well. But the 10 northeastern states started this process back in '03, I think, but are hoping to have the cap-and-trade program up and running this year. What's very important about that cap-and-trade program, if you know nothing else, it's like allowances when you were kids. Every time you emit, I'm going to use him in person, every time Eric emits a ton of CO2 from one of his generation units, he needs a piece of paper that gives him permission to do that. That thing is an allowance. And one of the major public policy issues is whether or not on day one when we start operating the program, we give allowances away for free or we auction them. The Regional Greenhouse Gas Initiative perspective has been one that's also been used in the European Union, which is that those allowances should be auctioned. They should be sold on a market in order to establish a market price for carbon, and the proceeds from that auction should be plowed back into the state for energy efficiency. And that's the model that we're hoping to use for one sector, which is utilities, and for the broader multi-sector world, I happen to believe that I can easily see a way to get to refineries and cement kilns and places that have big pipes coming out of it. The question, the public policy debate that's happening in Washington is whether you can do the same thing for, say, the transportation sector. Can you cap a sector and then make meaningful reductions in it when you don't have a pipe out of which everything comes?
Let me make a comment on the cost issue. From one perspective, I think Eric is right in that we have to be prepared to pay more for certain forms of energy. We don't know how much more exactly. We don't know what it'll take to bring in cheaper photovoltaics, for instance, or cheaper wind, or how fast that'll happen. So if we're serious about this problem, we have to be prepared to shell out a bit. But if you step back from the broader perspective, there have been attempts, and it's very hard. It's like projecting into the future, big uncertainties, to estimate how much it would cost to, quote unquote, solve or begin the process of making substantial emissions reductions. The IPCC looked at that. And it turns out that if you look at the 30-year time frame, and if you look at the whole world as a whole, you're looking at costs of about 1% of global GDP over that period. Now, you know, it's not nothing. If you multiply it by the GDP of all countries over that period, it turns into a very big number. But in terms of opportunity cost, how much did it slow down the global growth? It probably would never be noticed. The real problem is the political one of who those costs fall upon. And it's solving that part of the problem that is the most difficult one. And political leaders, no matter how great they are and what their expectations are, and we have some good leaders here in New Jersey, I'm convinced of that, are not going to step too far ahead of what they read that the public wants. So it's really, in the end, up to your expressions, and you should go vote for it.
Okay, question? Yes, ma'am.
Yes. Seeing that the majority of our population in the Northeast and here in New Jersey is along the coast, and there's a tremendous amount of energy off of our shore, not only wind, but also wave and current, which, if we could get some of these technologies put into place, there isn't as big a transmission differential from the shore, 2 miles off, for instance, coming into these heavily populated areas. How come we're not making more strides into wind? I know there was a number of people that were interested in putting in multiple wind plants off Long Island and also off the coast of New Jersey. And, you know, you started to touch on that. Could you go in a little bit deeper on that?
Yeah.
Eric,
You want
Why
to
don't you go
second?
first?
I'll do policy, and then he can do the private sector position, I guess. You know, the wind projects, I'll start at the end, that you talked about were killed by either public opinion, in the case of the project up in Cape Cod or Nantucket or wherever it was, if it's dead or it has been slowed, or in the case of Long Island, and this is very important, the economics just collapsed. The price of steel is extraordinarily high, and the private developer, because at the end of the day, this was a private, you know, investment, said we can't do this anymore. And indeed, I don't have any access to the bids that just came in, but I would hazard to guess by the scope of what is being bid that these are not cheap enterprises. And one of the major issues will be how we as a state would pay for this pilot investment in such a sort of sexy renewable resource. There are, and I'm not up to speed, maybe Eric is, on lots and lots of ideas for other renewables, and certainly wave and current action is one of them. I would say just this much from public policy, and then I'll turn it over. The idea of an energy master plan, besides wonderful goals like that, is to send an economic trigger, to send a signal, to the economy, to say this state, from a policy perspective, is going to do what it can to move in that direction and will regulate to that direction. So there will be energy efficiency standards, portfolio standards that he'll have to show, and renewable portfolio standards that he'll have to show the Board of Public Utilities, all designed to prime that pump and say to people, come and invest and figure it out, because there'll be a market for that here in New Jersey.
Just picking up on this, Lisa used the words price. Okay, there are technologies out there. There's a lot of experimentation around with wave machines. There's on the East River in New York, testing out one of those right now, even tidal flows, okay? It anchored something to a barge, and it was being tested to actually, I think it was generating a few megawatts of power. The issue really is, though, we need, all these price, the higher the price, the more the technologies become more attractive. And so if your policy has been one to depress pricing, the new technologies don't come in. You can create incentives, my example of the rebate program and so on, but what you really need is a price signal to stimulate the new investment. That's the reason why the gentleman up in the audience asked me, said, well, what's about the cost in the, if we don't do anything in terms of climate? I mean, it's enormous. I mean, we hear about the flooding and everything else. What the key is, we need to somehow carry from the future back to the present what that future cost impact is and reflect it into the marketplace. So we're making the right informed, let the marketplace make the decisions, and that's what the cap and trade program is supposed to do. It's reflecting it in as a CO2 price. Every ton going out the stack has a price to it, increases the price to that particular generator. They're going to look for either more efficient generation equipment, or they're going to look for capturing equipment on the back end of that fossil power plant, or they're going to look for other types of generation, like renewables and so on.
Do we know that the public won't pay more for something that is good for them? Do we know that if the public is presented with a case for flooding and whatever kind of disasters that Michael was pointing out, and you say, you know, if you pay 2 cents a kilowatt hour more for your electricity, we might be able to alleviate some of this. Do we know that as a fact, or is it just assumed?
No, well, I think there's a lot of examples where there's a recognition of a problem that needs to be fixed. Let's use the case of reformulated gasoline. Clean Air Act passed in 1990, recognition that ground level ozone problems is a significant problem from a human health standpoint. A lot of problem of that is related to VOCs emissions that were from gasoline, the reformulation of VOCs and NOx. And so when Congress passed this, the reformulation costs had a cost to it. And we have countless examples. Another example would be the Montreal Protocol, eliminating CFCs or eliminating lead in gasoline. There's countless examples of the willingness of imposing a cost to make change. It's just what is the crisis or what is the issue that needs to be fixed.
I'm not sure that answered my question. Maybe I didn't frame it right.
Let me try and then I'll...
But
I feel like I'm...
do you know the point I was trying to make?
Let me try one very quick experiment. It'll only take a second.
Okay.
Raise your hand if you're fortunate enough to have to pay your own electricity bills, because some of you are students and maybe you don't, right? All right, now leave your hand up if you choose to pay more through New Jersey's Clean Energy Choice Program so that you have renewable power as part of your generation portfolio. So 13, 14 cents a kilowatt hour. I think I pay now 19 or 20 when the bills are kind of different. So it depends on how much you use, how much more, right? But I mean, it's a choice you can make today.
Well, let me ask it in a different way. Okay, can I just, would you be willing to do your laundry at 10 o'clock at night if it cost you less in electricity to do it than to do it during the day? Raise your hand. If it costs you less to do it,
they're up.
now we've got an incentive going. Why can't we lower that price at night? We have the internet. We have ways of keeping track of people's washing machines and dryers and utilities and their meters. Our meters are read all the time electronically without our knowledge when they're going by. Why can't we find out when people are using their stuff at night and paying less money?
I encourage you to let the Board of Public Utilities know exactly what you just, your point of view is. Okay? Because that's exactly what we're saying.
We have changed history, ladies and gentlemen, right here in Montclair. So you owe yourself a A round of applause. Michael, yes.
Let me make a comment about that. I mean, there are several ways to get at this from. One is public survey data, in which people may not tell the truth about what they really feel, but nevertheless, it does indicate pretty broadly that people are willing to pay an interesting amount more to protect the environment, particularly from this problem. But people don't, one thing people hate is higher taxes. So that seems to not be a good route for doing any of this. And the other part of the problem is people say voluntarily, as you did, they'll pay more, but when push comes to shove, unless there's some guarantee that other people are also going to do it, you can't really see the benefit that's going to happen. So the number of people that do participate in green electricity programs, which I do too, by the way, are not that great because they're waiting for everybody else to do it too. And that's what government used to be for, is to solve the cooperative action problem. But we've gotten into an era where government is no longer thought to be capable of doing so, and I hope that that turns around pretty quickly.
People were very happy to turn in all their rubber and plastic and aluminum and copper during World War II for the war effort. They sacrificed all kinds of stuff.
We haven't had the political leadership.
Well, that is the point. We don't consider this to be a real crisis, right? No one has painted the picture well enough for the public to tell them we are in a crisis. I could pull up words from Jimmy Carter in 1979 that, you know, talked about this is deja vu all over again. Yeah, right. But speaking of Yogi, you know, there is no sense that we are in a crisis here. Andrés?
Well, I just going to say that in California, our local utility, Pacific Gas and Electric, has a program where they will purchase green electricity and raise the rates a little bit. And so far about, I believe it's in the 14 to 20% range of people who have already signed on. But the other picture is to look at it globally and look at what countries are really leading in terms of renewables. And we see a lot of solar going in, most of it right now going into Germany, right, and Japan. And these were things that we started here in the 70s, but they're expanding. What about wind? Well, again, started in California, and now where is it? It's Denmark and Spain. So it's how can they create the mechanisms? How can we recreate mechanisms here that will really start to flourish some of these ideas and then create the programs that will expand on this?
Question from the audience. So we have right there. Go ahead.
Oh, me first?
Don't hurt yourself back there.
I won't. And previously, Dr. Oppenheimer in his slides mentioned that we can trap greenhouse gases underneath the ground. And he also mentioned that we have samples from the inside of the, I assume, glaciers, atmosphere samples. So would it be possible to store these greenhouse gases inside the pockets of ice, and then that way we know that they'll be stored there for long periods of time like the atmospheres?
Well, interesting question. Two things could be said about that. One reason that storage underground rather than under ice is thought to work is because there are formations that are very hospitable to carbon dioxide, and that as you put more carbon dioxide in, the carbon dioxide seeps in deep into those formations, undergoes what's called a phase transition, almost like turning to liquid, and therefore you can pack more and more of it in. That would not be true of ice. And of course, we're melting that ice very fast. So it'd be if you could do it, it would be a bad gamble. Because if you were able to stick carbon dioxide under ice, and then all of a sudden you melted some of that ice away, you might be stuck with an even greater greenhouse effect.
Are the Chinese any closer to agreeing to change their ways?
You know, yeah, I think they are. There's several changes happening in China. First of all, the leadership there finally has acknowledged that global warming could be a big problem for them. They have a lot of exposure along the coast, tens of millions of people living in low-lying deltaic areas, and a food issue when they look at the maps for where drying is likely to occur. And so they issued a report last summer, which for the first time acknowledged that something has to be done about the problem. Of course, most of what they said needs to be done was that the United States has to pay them with new technologies. That's a first negotiating position, though. Secondly, China has a terrible air pollution problem and looks to the possibility, or I hope they will look to the possibility, of taking care of the fossil fuel problem generically. Third, China's interested in carbon capture and storage. And fourth, they have a very important nascent environmental or civil society movement, which I think will move the government on this eventually. Not the next 5 years, but over the long term.
My own personal opinion is that nothing will move them faster than a couple more athletes dropping out of the Olympics.
This may happen too.
Thank you.
I first had a question for Dr. Oppenheimer. You said a lot about the raising sea level, but you didn't really mention that much about the Gulf Stream and whether those ice caps would stop the current and the effect that that would have, or some kind of timetable as to when that would occur. So I wanted you to speak a little bit about that, and also for Ms. Jackson and for anybody, at what point do you stop worrying about what initiatives we should take, and when do we start coming up with a disaster recovery plan, say if the Gulf Stream stops and we do have some sort of ice age to come about, or a meter raise in sea levels? When do you start focusing more of the time, energy, and money on how we're going to save people's lives rather than how we're going to charge companies money for using CO2?
All right, with regard to the Gulf Stream, it's part of a larger ocean circulation called the meridional overturning circulation. And that circulation during the ice ages before 20,000 years, well, before 10,000 years ago, stopped and started several times, apparently causing abrupt climate changes, which, if they happen today, would be very difficult to deal with. The latest climate modeling, though, suggests that while the Gulf Stream and the associated circulation would probably slow down in a warmer climate, there's no longer very strong evidence that, except for a rather large warming of the sort that we may well get, but after the ice caps become exposed to melting, except for a large warming, it appears not to be vulnerable to a shutdown. And the theory that that would bring about another ice age was disproven. I wouldn't say disproven, but fell into disrepute quite a few years ago. So the latest thinking is that while this is a threat, it's a concern, the greater concern right now, the thing we'd have to worry about first, is what happens to the ice sheets. And on the theory that people have just a limited amount of things to worry about at once, I don't like to lard it on too much.
Okay, question on this side. Yes, ma'am.
Ira, you made the very important point that there's a lack of leadership, and I would like to understand that. Jimmy Carter was made fun of when he suggested people put on sweaters and then change the thermostats. What do you say, I ask all the panel members, what do you suggest to us? Some of us are the youth. I'm a little bit older than most of the MSU students here, but what would you propose? Because to me, this is urgent, and I look at my nieces and nephews and I wonder what kind of future do they have?
Andrés?
Well, I would answer that by saying that there's two angles to this. One is the technological solutions and technologies that we've discussed. The other one is the behavioral, in terms of changes that we can make on a daily basis. But beyond that, I think it's important to focus on the positive, on what we can do, and on the opportunities, as opposed to the cutting back. I mean, the greatest unlimited resource we have is our imagination and our creativity. And if we can work with that and come up with the solutions, there are tremendous opportunities out there in business, in research, in all these areas. So if we can focus on that, and often when I'm asked, well, what can I do? I say to the audience, well, think of what has meaning and passion for you, and then start there. Connect with your friends, connect with the colleagues. At the school, you know, if you're interested in working on food issues or energy or water or waste, find out who else is interested, form a group, and then start talking to your faculty, see how this can be incorporated in your courses, then start talking to the administration. And lo and behold, you'll realize that nationally there are so many campuses and colleges that are moving extremely fast in this area, and they're having National Recycle Mania, which is a whole contest on recycling and waste reduction. There's dorm energy competitions going on out there where dorms get together and compete with each other on who can reduce the most energy with prizes. So there are all kinds of incentives and ideas for communities. And colleges are really our labs. They are small villages. They deal with many of the same issues that other towns deal with food, with energy, with transportation. So how can we tap into that and then incorporate and see what changes can happen?
If I could just add.
Eric, yes.
I actually read Andrés' book, okay, and it's pretty fascinating because what he is, and I'm also on this board called Clean Air, Cool Planet, and it has the same item here, which is really, it's engaging civil society, and you refer to as the sustainable revolution. we kind of refer to it as engaging civil society to actually address climate change from all elements. But what you're really doing is building constituents to ultimately affect the public policy process. When there's enough people out there believe that it's a real issue, and it needs action, it needs public policy action, okay, at the end of the day, things will happen. It's nothing more disheartening than go down to Washington, D.C. And it's only now recently that they're really debating climate change. In the prior Congress and when it was the Republicans there, I used to do the federal affairs down in D.C. I used to tell my management, it's like a new world. It's a whole different world down there. It's environmental issues are totally different down there. It's the issues on market issues, societal issues. There's an element inside the country from the Midwest, Southeast, different parts that, quite honestly, I'll tell you the truth, a lot of people don't think the same way as the people in this room. We need to change that. There needs to be a dialogue. We need to make sure that we're having an impact on the policy process to get this thing done. So engage other universities in the Midwest is what I'm going to...
Well, I think one of the debates or one of the issues that has always been talked about is the negative side, is that we do have to sacrifice X, Y, and Z, but there's a huge upside of it that there's a lot of money to be made by companies going green. All you have to do is look at Wall Street these days and see what kind of investments are going into green companies. Absolutely. A lot of money going to these green companies and these startups and entrepreneurs.
And it takes a different perspective. Instead of thinking so short-term quarterly returns, you think further out. Same with buildings. Think about the operational savings you might have if you construct an environmentally friendly building. So it's a different perspective. It's a shift.
But I think it's also in terms of what personal choices you can make. Many of you are already, if you live in Jersey, you may have already bought your first automobile. The largest contributor to global warming in our state is actually via the transportation sector. So it's not just the choice of your vehicle, it's, you know, that great hybrid SUV thing, but it's also where you choose to live, where you choose to work, how you choose to live. And a college campus is more than just a lab. When I talk to college kids, I like to say to them, remember how you live now, where you can literally stumble out, walk out at some point and find food and beverage and friends and society, all set up so you don't really have to go too far and be safe. That model is all that's going to actually get those transportation numbers down in a meaningful way. We will spend the next 20 years searching for the next low carbon fuel and figuring out the infrastructure for it for another 10 years after that. But the truth of the matter is you have to figure out a better way to get around, to walk, to bike, to carpool. How many of you carpool? How many of you, you know, can't stand the inconvenience? Those kinds of personal choices, I don't think you can ever legislate. I absolutely agree. People have to see it as life and death and mobilize to do it, as, you know, this region did after 9/11, when suddenly there was just a public will to do something. We have not reached that point.
You have to, you know, other simple decisions. You have to give up that bottle of water that comes from the South Pacific. Right. Is shipped in from the South Pacific. And every bottle of water you buy as bottled water takes 4 bottles of water to make that 1 bottle of water. So, I mean, there are, you know, I'll never forget a couple of years ago, I was talking to a scientist about the whole carbon footprint. And he said, you really have to think about where the energy is flowing. He said, most people, here's a little thought game. He said, is it better to drive your car down to the grocery store a half a mile away to pick up a quart of milk, or is it better to walk down there and bring the quart of milk home? Now, everybody would normally say, hey, it's better to walk down there and bring that quart of milk home. He said, but in reality, if that walk makes you thirsty enough that you want to drink 1 glass out of that quart of milk, it takes more energy to make that 1 glass of milk than it does to drive down and pick it up. Agriculture being so energy intensive in all the stages of making that 1 glass of milk. So it takes a lot of thinking about, you know, where the carbon cycle and the energy cycle goes to. Who's got the microphone? You got it? Okay, use it. Go ahead.
First of all, I want to say that I'm not so happy about the meeting.
Speak up a little closer.
I'm not so happy how this meeting is going. It's turning into a blame game yet again. We're not supposed to be blaming each other here. We're supposed to look for our solution. And first of all, you have to realize you live in a capitalistic system. How many of you have credit cards?
Many are.
Whose money is that? If they decide to put a freeze on that money, what will you do? It's not your money. So first of all, look at the system you live in. This is a capitalist system. Stop blaming the government. If you want to blame the government, have a socialist system. That way you can direct all your problems to the government. In this environment, the businessmen control you. So until you will come up with a solution that they agree with, they will never put any venture capital towards that idea. All these things you're talking about, wind, algae, yeah, they're all good. They're not so bad. They're all so good. But if they will tell you, give it to Mr. Stevenson there, he will look at it and tell you, this is how much it cost. Are you ready to pay the price? It won't be able to return the venture capital in the final end because you're talking of serious money in it. So the best thing is for environmentalists who want to really do something for the environment to go into business for the environment. Start thinking like Mr. Stephen there. He's the right person here because he's telling you the real world. You guys are talking about algae, wind. This is a temperate climate, for Christ's sake.
So we should think of the environment as a business, is what you're saying.
Go into business for the environment. That's the way to go.
Okay.
So when you approach Mr. Simpson there, you are an environmentalist, but you are giving it a business idea. You are giving him something that is, I call it, the best available, sustainable technology to work with. All those wind, whatever, you live in a temperate environment. How long will that wind work? When it comes to winter, how will the solar panel be working? Who will be providing where will the energy be coming from? So you see all that. So he has to think of all that because he is the person who is in charge of giving you what you need. If you go tonight and find that there's no power in your house, whom will you call first? Of course, him. And he tells you that, oh, sorry, man, the solar system failed somewhere in the day. I mean, there wasn't enough solar power to power, energy in the sun to power everything. So that's the only reason. Give him the idea that is sustainable, that will make Mr. Trump, for example, give you venture capital. That will save all of us. Otherwise, all these little ideas we have, this is the United States.
Okay, I want to give someone else. We're running out of time. There's no question there, so I'll just say that was a manifesto or something, a statement. Anybody else? Who's got the microphone? Whoever has to stand up and use it. Go ahead.
Hi. I have a slightly different perspective on what some of the barriers are. I was in state government 17 years ago when we started some very early global warming efforts, and I was able to watch an evolution of thinking. But there were certain huge obstacles back then, and they still remain in certain ways, particularly at the local level where I'm working more and more. And what it is, I think, is a reluctance to challenge conventional assumptions in terms of what is doable. You know, back at the state level, back then, the feeling was global warming wasn't a state problem. We finally got over that one. And then you had to do things in a voluntary way. You couldn't do anything mandatory. You couldn't even say the word global warming. You had to say sea level rise. Gradually, we've overcome some of these things, and a lot more people are interested in these issues now, and we're prepared to be more ambitious. But I'm still seeing the same problem. Until present company accepted, there's a reluctance to say anything about lifestyle change within state government. You can't say behavior change. You can't talk about a carbon tax, although it's probably the only way we're ever going to get to our very ambitious goals. Talking at the local level a lot, I had a very progressive mayor say to me that anything that he does on global warming has to pay for itself, which I interpret to mean it's the lowest level thing that a locality can do because nothing else has to meet that test. Plus, when it comes to economic development, I would guess that we have very few companies that have agreed to become carbon neutral. I could be wrong, but if I'm right, I don't know why that is. I don't know why both government and consumers are not encouraging the state's industry to become greener in that way. So if you agree with me, how can we speed up this questioning of conventional assumptions if indeed this really is the urgent problem that we think it is?
Michael, any thoughts on that? Any thoughts on how can we think outside the box, or Lisa, you want to?
Yeah, I think, well, I know Matt, so that's an unfair question. I think that he's absolutely right in the sense that, you know, his big frustration when he first met me was that I seemed to be afraid to be truly innovative. And I think...
failure of the imagination.
Failure of, well, you can dream it. It's getting it done. And I leaned over to you when we were watching the end of your slideshow, and your last slide says something like we have to be flexible in order to respond to changing science, and I made a crack, which is, yeah, because government does that really well. We want to. I do believe that there's will. One of the things I like to brag about New Jersey state government, we get a bad name, or New Jersey, I won't say the government. We get a bad name for environmental issues, but we've been first a lot of times. A lot of the innovation on environmental programs came through us. The Superfund came from this state. The response to Bhopal came from this state and then was adopted nationally. And we're hoping when we look at something like the Regional Greenhouse Cap and Trade Program, we will help to be a model as well. So he's absolutely right that we're not going to crack this last nut until we find a way to not necessarily command and control human behavior. I have 2 kids. I can't command and control them. So all the tools that a regulatory agency feels most comfortable with, which are, permits and enforcement and cap and trade, we're kind of getting better with that. All those things won't really make the change that will actually get us to the next level. We can't regulate it. I like to tell people we have reached a point in the environmental policy world where it's actually back on us again. We looked at the burning rivers and all the stacks, and we did a lot of things, and we'll keep doing that, but we have to change that. And that's where education and changing behavior and making people feel the imperative and ownership of it is hard. The one thing I'll say on that is that I think the creative and seed use of a real offset program, not an offset program that makes people feel good, but a real program with verifiable changes would start to capture the energy, because there's a lot of energy out there. Everywhere I go, somebody wants to show me their new sustainable school, their LEED certified building, their solar panel. It's not that people don't, and we happen to be affluent in this state, so we have people who have the ability to go out and do it, but we're not capitalizing on that to create this kind of,
So there is that realization. You go to the schools and you see that people realize this, but and that's why I'm saying, and I'm agreeing with you, how do you capitalize on that cognizance? Andrés, you have an idea?
Well, I think part of it is really engaging the citizens and really becoming active citizens. In the county of Marin in Northern California, they had to redo their county general plan as an upgrade. Every so often they do that, so they just did that and started, and they got focus groups. And the first group was the people to say, let's decide what our guiding principles are going to be for this. Our sustainability principles for the county. Came up with that. It took a long time, but that came out. Then they had certain focus groups on food, on energy, on transportation, on all of these different areas for the county, and came up with a plan like that. Now, it took 6 or 7 years to make it happen. It just got released, but it's one of the first sustainability-oriented master plans for a county in the country. And what it took was really engaging the local citizens and having them be a part of it. When, at a national scale,
so let me just interrupt that for a second. How did you engage those citizens? What does California know that New Jersey doesn't?
Well, I think the way it was done there was there happens to be a lot of people who have an inclination and an interest in these subjects to begin with. A lot of people who write about this stuff, who study it, who research it, and then it's getting in touch with them and then having them be a part of this process. So I think it's capitalizing on the vision for the local community and how each one of us can make a difference if we bind together. And it doesn't take a whole large group. It just takes a small group of committed people. And that's how it came about. And also sticking it out, because it's not going to be easy. And even when the county plan is out, now there's lawsuits that are going to be involved. So you just work with it and you have the long-term vision. Again, it's a shift in terms of not having a quick, easy answer, but realizing that it's going to take time. But for it to be really long-lasting and visionary, you just put the work into it.
Eric, did you want to say something? I interrupted.
There was a quote that was attributed to Napoleon years ago that said, "My troops are marching, I must lead." And it's a little bit of the same effort here, is that politicians are not rewarded to getting too far out in front. When the body politic moves forward, the center of gravity moves, it's incrementalism, and it feeds on each other. And I think that the sustainable revolution that Andrés has written about and that Lisa also has talked about what she sees and so on, we're now getting a momentum. Things are happening. Even for my company, a lot of times first movers have not been rewarded. Sometimes they can really be hammered in the marketplace.
Michael, did you want to say something?
Yes, I mean, I think I want to pick up on something Eric said about these things interacting with each other. I don't want to give up on the efficacy of regulation so easily. If one looks back on the history, and we do look to the period in the 70s, which is somewhat analogous to today, the most effective part of the so-called energy policy that was implemented then was the CAFE standards. They changed the way motor vehicles were designed. They eliminated the growth of motor
That's the
vehicles.
car fuel efficiency standards.
They eliminated the growth in fuel use for a very long time. They were timed in a way that conspired with high oil prices so that the two things worked together. The public was ready to accept the regulation when it was laid on them, and it kept oil use down for about 15 years until in 1985, actually, the prices dropped, the bottom out of the oil market. The public interest in saving money went away because oil was cheaper. The companies started looking around for loopholes, and they found that big SUV loophole, and to a lesser extent the alternative fuel loophole in the existing CAFE law, and the thing eventually was weakened. Nevertheless, fuel economy of the whole fleet today, even at the nadir actually, was about 60 or 70% above what it was before fuel economy was legislated in 1975. So it's an interaction between regulation, a cultural shift, which I actually think can happen relatively fast, but it's really a long-term thing. It can start, but it's not going to be, we're not going to have a revolution overnight. But there are signs things are changing. You know, I used to not believe in green markets because everybody in marketing told me, you know, everybody says, but nobody will put the pennies down. It's worth, you know, like less than 1%. Any little margin for greenness, nobody will buy it. That's changed. And today there is real value in getting green products out there. So I think the attitudinal revolution is happening, and it creates enough space for political leaders now to do their part. That's what's next.
Question of it? Yes, sir.
This is for Ms. Jackson. For policy in New Jersey, is there any initiative to make buildings green, like to have plants on the rooftops or to have them outfitted with solar panels, since you can trap CO2 in the biomass of plants?
Okay, thanks. Well, there's two things that are happening in the legislature right now that I think you can be helpful as if you're voters, if you're residents, to be vocal on. The first is building efficiency standards, and the second is appliance efficiency standards. And you know, I'm an engineer, chemical engineer by training. I thought I was getting in the pollution business, but I have learned more about energy in the past couple of years than I ever thought I'd know. But apparently our laws in New Jersey hold building codes, our uniform construction code, to be no more stringent than the federal numbers, the federal code. And so if you want to really make a drastic improvement so that when we start building again, because we're not building very much right now because the governor today said he believes we entered a recession last quarter. But if we start again, you get ready by signaling and then regulating and making it mandatory that our buildings must be much more efficiency, because homes, you lose a lot of energy. Then there are appliance standards, which are also up in the legislature. And I think when you talk about political will, that seems like it should be easy, but it costs money. And the contractors and the folks say, well, now that's going to make the homes more expensive, people aren't going to buy, and you're slowing down our housing market. Oh, my goodness. So, you know, you need to have your voice heard there. On the LEED side, on the idea of more sustainable buildings that look at everything from energy use to water use, which is huge for us, to conservation, and then green roofs and storm water and all those good things. There is a voluntary and sort of sustainable movement afoot. My favorite example is our School Construction Corporation, which builds schools in avid districts. Right now we need some more money. But they've adopted life cycle analysis for the designs that they use for their buildings. So it's not an accident I go to schools now that are LEED certified. or close to LEED certified, is because that's the design standard that the state has now mandated. And it's cool when you see an independent agency like that, but there isn't anything mandatory for residential. There is lots of talk at my agency, for instance, that we would start to use the regulatory process not to require green buildings, but to incentivize them either through permit fees, permit strategies that would say to people, well, you know, that permit's going to take a while to get, but if you come back in and redesign your building in a sustainable format, we could put it on top of the pile. I mean, we're starting to do those kinds of things, but there is no requirement.
Yes, sir.
I'd like to address this to Dr. Oppenheimer, but the panel as a whole. We've been talking about an energy crisis of sorts, essentially the byproducts of energy utilization and the increasing rate of utilization and increasing the byproducts. These are also finite resources, and you hear and read recently with the growth, and I'm really struck by this slide, third world countries, some of which are not such third world countries anymore, like China and India. These are resources that are now, there's more concern about the rates at which they're diminishing. I think we have a crisis of scale. You know, what do we run out of first, the oil or cool air? It strikes me we need a national policy, and it may start with things including national security and self-sufficiency. What can we do to replace petroleum hydrocarbons, or let's say just the oil component, if we are at a new crisis intersection on the same temporal scale, decades to 100 or so years, you know, a couple of centuries? What do we do about that?
Well, first of all, I don't know whether we're near peak or not. No one really knows. There are different views. But I do know that we're not going to literally run out of liquid hydrocarbon because they'll just start making it from coal, which itself is a disastrous alternative because it creates twice as much carbon dioxide per unit energy extracted. So ultimately, for a liquid fuel, we're either going to go, one suggestion is biofuels, but aside from the issues that we raised before, there isn't enough land capacity to really do biofuels to more than maybe 10% of global fuel supply. It's simply not there. The land, it competes with growing food. We saw that already with the price of corn when people started producing ethanol out of the Midwest. So that's not going to be a big part of the solution. The only credible, really long-term solution, assuming that we're going to keep a big transportation sector, and that's maybe a big if, is something like hydrogen generated by either nuclear plants or solar photovoltaics, which is then piped around, used in fuel cells in vehicles, for instance. That's one suggestion on how to do it. There are a couple of others. But again, if oil prices keep going up and we don't have restraints on greenhouse gases, you will see the slide towards synthetic oil, which will just make the greenhouse problem worse. So in the short term, we really need those greenhouse gas limits, or else we're going to be in even a much worse problem.
Any other questions? Yes, gentleman right here. Is anybody on this side that I'm missing? Over there, okay. We only have time for a couple more questions. Yes, go ahead.
Oh, one point and then a question. The point is to show how daunting this all is. The anticipated demand is so great that in China, they commission a new coal-fired plant about every 7 days. And the question is, do you think that we could really avoid disaster in the absence of, at a worldwide basis, in the absence of population control?
Well, let me answer that one. One of the bits of brightness in this otherwise sort of grim picture is that the rates of population growth have decreased. Because of decreases in fertility rates almost worldwide, even now lately in some African countries which had been slow to stabilize and decrease their fertility rates. And when I first started thinking about this problem about 25, 30 years ago, the projected global population was about 16 billion. Now the projection for the stabilized level of global population is 9 or 10 billion. And the reason is a combination of efforts to improve the status of women, get accessibility to family planning information, and the demographic transition in countries becoming more wealthy. Now, a planet with 9 billion people is still a lot harder to manage than a planet with 6 billion people from a greenhouse gas point of view, but it's a hell of a lot easier than a planet with 16 billion people. So some progress has been made there.
I think we have time for one more question on this side of the room. We got somebody over here? Yes, right here in the aisle.
Hi, I wanted to maybe shift gears a little bit, talk about the Skylands watershed. And that is also a pressing problem in this state. You mentioned water and drinkable water. It's a problem around the entire world. One of the things that I see, my brother-in-law is a contractor. And he's a really nice guy, and he was a hippie in the 60s, so you think he's really close to the earth. But he's fighting like hell to have the right to develop that tract of land. And we almost have a perfect storm here for the past 8 years. We have cheap capital, which you walk down the block and you're going to pass 6 banks. And 6 banks are there to lend, to build houses, and to develop. And we have a regulatory or governmental regime that is absolutely against any type of regulation. So we have these developments, these unplanned developments going up. So I think that there's some very deep-seated systemic issues in terms of creating true sustainability models that are going to protect the environment, and specifically the example being the Skyline watershed. Thank you.
Any comments? Lisa? Jump into that, but grab the hot potato.
That one's hot. We have, not in the Skylands, but in the Highlands, we have the Highlands Water Planning and Protection Act, which in this state, if you don't know, we have, about 400,000 acres where development is severely constrained. I know because we wrote the regulations for it, and within the context of a law that was written to allow single-family housing, which in itself is kind of a sprawling pattern of growth, unfortunately, that area is fairly well regulated. Outside that, another 400,000 acres that is supposed to be, a model for smart growth. And right now, there's a regional master plan for that area, which I think is going to be a litmus test in terms of people's willingness to make hard choices about channeling growth into areas and leaving other areas alone. And this state, I think, has come full circle from being a real leader on land use regulation and preservation and planning to being sort of a leader, to having all the will to do it, but realizing that even now where the subprime mortgage crisis says we're on the front end of maybe losing a couple $1 trillion out of that market, even now people are joining battles about property rights and rights to develop that are about individual rights versus sort of this collective good. So I think those issues will continue, and I think the thing that will actually do it again is going to have to be public engagement, because at the end of the day, we got to get people to stop wanting to live in the beautiful Highlands or Skylands unless they happen to be in a hamlet or a village or somewhere where there's transportation and infrastructure and water and wastewater in order to support them.
Well, we've run out of time. We've come full circle. Michael, I want to ask you one last question, and whether you've painted a pretty bleak picture up there about what the possibilities are for the future. Are you yourself bleak, or are you optimistic, or do you have no choice but to be optimistic about
Well, you're either born an optimist or a pessimist, and I was born an optimist, and maybe that's the only reason I can work on this problem. But the way I look at it is we're not going to know for sure for a while. We have to live with the uncertainty, both because these projections are uncertain and because we're uncertain about the way the political system will respond. And it's not going to be obvious. All we can do is start the first steps. And the way I look at it, I hark back to when I was a kid, and we were diving under desks to avoid being blown up by the Russians. And if you remember, Jack Kennedy made this famous speech at American University in 1963, shortly before he was shot, where he called the Cold War a twilight struggle. Basically thought we're just stuck in this thing indefinitely. It's never going to end, and we're not going to win, and we're not going to lose. But we came out of the end of the pipe on the Cold War. We came out of the end of the pipe on my kids don't have to dive under desks. They have other things to worry about. But we haven't blown ourselves up. And I think rather, I'm not saying we'll muddle through, because that's an ugly way to say it, but I do believe ultimately in the ability of humans individually and collectively to respond to such challenges. And I think we're going to do it.
I want to thank you all. I want to thank the audience, 500 people coming out on a weekday night. It's a testament to your commitment about the problem and understanding. Also, I want to thank Michael Oppenheimer, Lisa Jackson, Andrés Edwards, and Eric Svenson for taking time to be with us this evening. Thank you all.